Okay, what about now?
Yep, it's up. Looks great.
All right. For those of you that don't know me, my name is Jeremy Betts. I am the head of technical services for the Eastern US and Canada. Today, I'll be talking about our vision and solutions for lowering the carbon footprint with a focus on Portland Limestone Cements, or PLC. Presentation should take a little under a half hour. After that, we'll open it up for any additional discussion. I'll be giving a brief overview of who we are, our sustainability journey, and discuss Portland Limestone Cement, and then finally, how to use it, along with other cementitious materials, to lower the carbon footprint of concrete. Heidelberg is one of the largest vertically integrated companies in the building material industry. Number 1 in aggregate, number 2 in cement, number 3 in ready mix. At Heidelberg Cement, we have 3 stages to cope with the carbon challenge. Stage 1, scientifically recognize. We spent time for the past couple of years to develop roadmaps identifying needs and targets. We became the first and highest ranked cement company to have approval for science-based targets by the Science Based Target Initiative. Stage 2. We have published our 2030 sustainability commitments with a goal to reduce our greenhouse gas by 30% compared with 1990. Recent audit of our roadmaps and technology have given us the confidence to move the target up to 2025. The target reduction related areas that we are working on are the increased use of alternative fuels, lower carbon cements such as EcoCem PLC, which we'll talk about later, and embracing digitalization to have a closer connection with our customers that increases transparent communications to help us all curb waste. This is important as we reach for stage 3 and lead the way to carbon neutral concrete by 2050. This is in accordance with the 2016 Paris Climate Agreement. As a side note, in December of 2017, Washington, D.C. also pledged to become carbon neutral by 2050. We still have a long way to go on that journey. We are working on lower carbon concrete, new technologies, and especially the optimization of embodied carbon, recarbonation, and recycled concrete, as well as carbon capture for process emissions. It is easy to put on paper action items to reduce carbon emissions. It is another to put them into action. We are taking steps to ensure that we reach our 2050 goals, and at Heidelberg, we put our words into action. We have announced our plan to upgrade our Slida plant on the island of Gotland in Sweden. Currently in a feasibility study, the upgrades to capture direct carbon emissions and decarbonize the plant's energy sources would result in a 1.8 million ton reduction in carbon dioxide emissions annually by 2030. This will be the world's first carbon neutral cement plant. The upgrades in Sweden are not considered pilot approaches, as the technology to bring Slida to net zero emissions is already being used at our Brevik, Norway plant. The CCS technology at Brevik is a base model for the Slida upgrades, in which amine solvents are used to treat flue gas to capture CO2 for liquefaction and subsea floor storage. While Brevik currently aims to be 50% carbon neutral by 2024, following a feasibility analysis by Heidelberg, Slida is planning to utilize biomass fuel sources in the region for production, allowing the plant to reach for net zero emissions by 2030. Slida remains a huge focus for carbon neutrality, as the plant contributes to 3% of all of Sweden's carbon emissions and remains the largest supplier of domestic cement in the country. 80% of Heidelberg research and development investments are sustainability driven. This is done by research into our alternative raw materials and fuels, as well as innovative products. Some of our key innovative products are TX Active, a photocatalytic cement, which breaks down pollutants with help from the sun, and products like PowerCrete and CableSam, which is used for energy storage and heat transmission through its high thermal conductivity. If there is interest in these products, I'd be more than happy to set up another time for a more in-depth discussion. Before I get into cement production, I think that it is important that we are clear on the difference between cement and concrete. I'll be talking about both today, and there is actually a huge difference between the two. Cement is the gray powder or the glue that we mix with water and aggregate, which is rock and sand, to make concrete. There is no such thing as a cement sidewalk. It is a concrete sidewalk. So when I talk about cement, think of the gray powder on the left. And when I say concrete, think of the slab on the right. Now let's take a look at cement production, the types of cement, and the things that we can do to reduce the carbon content of cement. The cement production process is one where we take material out of the ground, grind it, burn it to make clinker, and then grind it again with additional materials. The easiest way to remember the materials that go into making cement is Lisa G. The L is limestone, the I is iron, the S is silica, and the A is alumina. These are what goes into making clinker. Then we have G. The G is separated because that is the gypsum which is added to the clinker in the final grinding process. Without gypsum, the cement would harden as soon as water is added. Now that we know who Lisa G is, we need to understand what we do to make her Lisa GL. Here's a diagram of the cement manufacturing process that I discussed a little bit earlier. With Portland Limestone Cement, additional limestone, 5 to 15%, is added along with the gypsum and clinker in the final grinding process, blue arrow. Carbon dioxide emissions for cement plants come predominantly from two sources: calcination of the limestone, a primary raw ingredient for clinker manufacture, and fossil fuel consumption to heat the raw materials to the temperature required to form clinker. During this process, about 40% of limestone mass is released as carbon dioxide. To produce a ton of Portland cement, about 1.3 to 1.4 tons of raw material are needed. PLCs need about 10% less primary raw materials. The primary sustainability effect of using limestone as an ingredient in blended cements at levels of 5% to 15% by mass is that less clinker has to be produced for an equivalent amount of cement, and therefore less energy is consumed and CO2 emissions and other greenhouse gases are reduced. The properties of Portland limestone cement are equal to or a little better than regular Portland cement. You're likely familiar with Portland cements. Portland cements are categorized into 5 types. Type 1, general purpose. Type 2, moderate sulfate resistance. Type 2 with the MH designation, which is moderate heat of hydration and moderately sulfate resistant. Type 3, high early strength. Type 4, low heat of hydration. Type 5, high sulfate resistance. Mixed designations also exist, such as type 1-2, which indicates that the cement meets requirements for both types. Types 1, 2, 3 are also available with a suffix A, indicating that an air entrainment addition has been added at the cement plant. Now let's talk a little bit about slag cement. Slag cement is a hydraulic cement formed when granulated blast furnace slag, GGBFS, is ground to suitable fineness and is used to replace a portion of Portland cement. It is a recovered industrial byproduct of an iron blast furnace. Molten slag diverted from the iron blast furnace is rapidly chilled, producing glassy granules. These granules are ground to a cement fineness, typically having a white color. We produce slag at in several different locations in North America. For the DC region, slag cement is made at our Camden, New Jersey or Evansville, Pennsylvania plants. Supplementary cementing materials, SCMs, contribute to the properties of hardened concrete through hydraulic or pozzolanic activity. Typical examples are fly ashes, slag, and silica fume. These can be used individually with Portland cement or blended cement or in different combinations. Supplementary cementing materials are often added to concrete to make concrete mixtures more economical, reduce permeability, increase strength, or influence other concrete properties. Since they are typically an industrial byproduct, their calculated GWP is significantly lower than Portland cement. We will see later how this can be used to lower the carbon content of concrete. When supplementary cementitious materials are added and blended at the cement plant, they become classified as a blended cement. Blended cements are hydraulic cements like Portland cements, and typically are composed of Portland cements and non-clinker materials, including SCMs and limestone. Typically, this is done by intergrinding the non-clinker material with the clinker. These blended cements in ASTM C595 are classified as type 1S, which is Portland cement clinker with slag, which we make at our Evansville plant. Type 1P, Portland cement clinker with ash or other pozzolans. Type 1L, which is Portland limestone cement, or type 1T, which has more than one non-clinker bearing material. For example, if we took a Portland limestone cement and we wanted to combine slag with it at the cement plant, it would be classified as a type 1T. The impacts of using limestone are appreciable. In this case, CO2 emissions are on the order of 10% lower for the manufacture of Portland limestone cements. Environmental Product Declaration, EPDs. When we go to the grocery store and decide what consumables we are going to purchase, a lot of times we'll look at the nutrition label. Coke is a great example of that. We all know that classic Coke is full of sugar and calories, and that Coke also has some other lower calorie options. We can find out what's in that can of Coke by looking on the back of the nutrition label, and the calories being on the top of the nutrition label is what we would translate to the GWP on the Environmental Product Declaration, which we measure in kilograms of CO2 equivalency. It is important to understand equivalency to ensure we are talking apples to apples. For example, methane's GWP is 25 times higher than that of CO2. This is an example of a type 3 or plant-specific EPD from our Union Bridge, Maryland plant. Later, I will show you how to use this EPD to lower the carbon content of concrete. Transparency is the new green. This type 3 EPD is a true reflection of the GWP from the various products produced at this facility. You can see that our type 1L has a GWP that is 55 kilograms of CO2 per ton lower than our typical type 2. By the end of this year, we will have type 3 EPDs for our cement plants in Picton, Ontario, Nazareth, Pennsylvania, Evansville, Pennsylvania, and our slag grinding facility in Camden, New Jersey. We have several customers in the DC area that will be able to take advantage of our type 1L and plant-specific EPDs. Our plant-specific EPDs from our Western US and Canada plants are currently being used on a regular basis. To access this EPD, simply Google Lehigh EPD, and you will be directed to a list of our cement plants in North America that currently have EPDs, including Union Bridge. LEED version 4.1 rewards the use of higher performing products. The range of report types included in the EPD option 2, embodied carbon LCA optimization credit, now makes it possible for concrete producers or manufacturers of all sizes and stages in their transparency journeys to demonstrate how they are credibly achieving measurable improvements by comparing with the industry average. Portland limestone cements have a long history. I don't have time to go into the history lesson for this presentation, but if you're interested in learning more, let me know. I do want to point out that the majority of the cement produced in Europe and Canada are blended cements. It is almost impossible to find cement that contains only Portland cement. In the US, even though we have a specification for it, C595, Due to specifiers being unfamiliar with it, sometimes only C150 is specified. As owners and designers, we need to ensure that C595 is specified along with C150. Here's an example from section 3300 for cast in place concrete, which shows that PLC can be used as an alternative. If you come across specifications that do not include C595 type 1L, either add them or request that it is added. Here's a map of 2014 of the United States showing acceptance of Portland limestone cement. AASHTO M240 and ASTM C595 published provisions for PLC type 1L in August 2012. About 16 months later, about 13 state DOTs have made changes to permit the use of PLC. The green states are those that have accepted Portland limestone cement, yellow is considering, and orange is not accepting. Let's fast forward to this year. As you can see, almost all states have accepted Portland limestone cement in state highway work. One of the holdouts was the state of Maryland, which is expected to be approved this year. You may hear that the limestone is an inert filler when added into Portland cement and does not improve any characteristics. However, the addition of ground limestone in the cement benefits the hydration process in 3 ways. The first is particle packing, similar to aggregate packing in concrete. The limestone is softer, so when it is ground with clinker, it becomes smaller and therefore fills the voids in between the coarser cement particles, which helps to create a denser hydration structure. The limestone also acts as additional nucleation site for initiating the hydration process. Think of this like seeding a rain cloud. And lastly, there is a slight carboaluminate reaction with limestone, which slightly increases strength. We have gone over what Portland limestone cement is and some of the specifications, but I wanted to make sure that we are clear on the different names that are used for Portland limestone cement. EcoSam PLC is Lehigh Hanson's brand for Portland limestone cement. PLC is the general descriptive term for Portland limestone cement, and in the United States, ASTM C595 cements are known as type 1L, or sometimes you will hear just 1L. GUL is a term used in Canada that comes from the Canadian standards. Type GU is a designation for general use cement, and an L is added to make GUL, which is Portland limestone cement. The most important thing to remember is that all of these names are referring to the same product. How does this affect concrete? I'll now be talking about Portland limestone cement used in concrete and how it can be utilized to reduce the carbon footprint of the concrete. So what happens when we use PLC instead of Portland cement in concrete? What changes to concrete properties can we expect? PLCs are manufactured so they can directly replace ordinary Portland cement with minimal change in both the plastic and hardened concrete characteristics, or in other words, equal to or slightly better performance. Here are some recent results from concrete testing that we have done in our lab. The concrete mix design is a typical straight cement mix. We ran one mix with ordinary Portland cement and then another replacing the Portland cement with PLC. Everything was the same for both mixes. Water, admixtures, aggregate, only the cement was different. On the left is the first mix with Portland cement. Gray column is air, important for freeze-thaw durability. Blue column is slump, which is a measure of workability, or in other words, how easily it can be placed. Just to the left of the slump column, you'll see a light gray dot. It may be hard to see, but that is the initial set time, or the time when the concrete starts to stiffen. And then on the right, we have our PLC mix with its air, slump, and time of set. The slumps are equal, the air content and time of set are within test air parameters. Basically, we see equal plastic performance. What these results mean is that for someone in the field, they would notice absolutely no difference between the two mixes. A typical job site sees higher variability from load to load delivered on site than we do here. All of the plastic test results look great. However, how does it perform with strength, which is what everyone looks at? If you remember the previous US map, the state of Maryland was a light green, which means that they are planning to accept the use of PLC in their state highway work. Part of getting that acceptance, the Maryland Highway Administration wanted to see Portland Cement and PLC tested side by side in one of their mixes at NRMCA. Here are the results of that testing, which was performed a few months ago. Mix 6 is a Maryland highway mix that is 4,500 PSI with a 0.45 water cement ratio, 650 pounds of cement per cubic yard. The first two blue columns represent 7 and 28-day concrete strengths made from Portland cement produced out of our Union Bridge plant. The other two blue columns represent the same thing, except with PLC from our Union Bridge plant. Even though the results from the PLC appear a little higher, we can see that the strength performance is equivalent. The green columns are the same testing, but from a different cement plant. It can be clearly seen that the parent clinker is the determining factor on the performance of the cement in the concrete. What this means is that you will see more of a change switching between cements produced at different plants than you will see switching out an ordinary Portland cement with PLC from the same production facility. Greener concrete. How do we make concrete greener? The fastest and easiest thing that can be done to immediately reduce the carbon footprint of your concrete is to use EcoSim PLC instead of Portland cement. As you saw in the previous slides, it is like for like and is something that can be done tomorrow. A ready mix company would see more change in their mix performance switching cements from a different source than they would switching to a PLC from the source they are currently using. How much of a reduction in CO2 does PLC make in concrete? What about using slag cement in our concrete mix design? What about other carbon reducing technologies like carbon cure? Let's take a look at what we can do to reduce the carbon footprint of a standard commercial concrete mix. Here we have a standard concrete mix, 564 pounds of cement per cubic yard. Using the industry average, our concrete mix contains 560 pounds of CO2. If we take that same mix and utilize PLC, we now have a mix that contains about 520 pounds of CO2. We can also reduce the carbon the same amount by using carbon cure. By switching ordinary Portland cement to PLC, you get the same reduction in CO2, in this example, 40 pounds, as you would if you utilized carbon cure in the mix. What about using slag cement? Here we have the standard 564 pounds of cement concrete mix again. Same example as previous slide, but with the scale zoomed out. The first is our plain Portland cement mix. The next is our carbon cure PLC mix. What happens when we add 35% slag to the plain Portland cement mix? We see a significant drop in our CO2 content down to 382 pounds. If we use PLC or carbon cure, that takes us down to 342 pounds of CO2, a 39% reduction. Remember when we talked about our 2025 goal of reducing our carbon footprint by 30%? If we utilize PLC and 35% slag in all concrete, with it having a 39% reduction in CO2, we would already be there. But we can't stop there. So what else can we do? Same mix as before. The red column is the Portland cement. Yellow column is PLC. White column is PLC with 30% slag. We can take that a step further. We can add 10% fly ash or increase the slag percentage replacement, which is the light green column. And we could also use a high range water reducer to reduce the water cement ratio from 0.50 to 0.45 and pick up 750 to 1,000 PSI. Now we can use the same concrete in higher strength applications, no additional CO2. And that's the dark green column. The result is concrete with a CO2 content of 306 pounds. This is a 48% reduction from the industry average. This is something that could be done tomorrow. and in a lot of instances is already being done. All concrete should be made with PLC and supplementary cementitious materials like slag wherever possible. As mentioned earlier, at least 80% of Heidelberg Cement's research and development investments are sustainability driven. Along with industry partners, some of that research has been looking at ways to calculate and maybe enhance the recarbonation of concrete. This naturally occurs when CO2 in the air reacts with calcium hydroxide, which is a byproduct from the cement hydration process. The Global Cement and Concrete Association, or the GCCA, is a good source to learn more on how this works. If you haven't already, I would recommend that you look at Castor Materials' LinkedIn page, where you can watch a video that features EcoSem PLC and a few cameos from our Lehigh Hanson team. Castor is actively promoting their low carbon concrete using EcoSem PLC in the Philadelphia market. I'll be sharing some of their projects on the upcoming slides. This next series of slides gives examples of projects in both the US and Canada that utilize EcoSem PLC. The following three slides are the project that I mentioned earlier being supplied by Castor Materials using our EcoSem PLC. Here we have Interstate 95 in Philadelphia County. This construction includes support footings, columns, beams, and bridge decks with 2.5 miles of long life concrete paving. In the Northern Liberties neighborhood in Philadelphia, we have Terminal Piazza. This includes 7 buildings forming the terminal, apartments, condos, parking garages, and retail stores. This is Drexel University's academic tower, a 20-story building housing the Nursing and Health Sciences Department. EcoSem PLC is also being used in the lightweight and high-strength concrete. Here we have an overview of projects in Washington, D.C., with the masonry components being made from low-carbon masonry units made by Ernest Mayer. Ernest Mayer is a family-owned concrete block manufacturer serving the D.C. metro area. They provide solutions to architects, designers, homeowners. Their manufacturing process utilizes EcoSem PLC and Carbon Cure. On the left, we have the MedStar Georgetown University Hospital. Upper right, we have the wharf parcel 6 and 7. This project is designed to achieve a LEED Gold rating. On the lower right, we have Lima Hotels Holiday Inn Express in downtown Washington, D.C., 14-story hotel. Now we move down to Alabama. At our Leeds facility, we have been promoting PLC. We have been producing PLC since 2007. To show our commitment to PLC in 2009, we did 2 larger infrastructure projects at our plant. One of these being a new day storage loadout silo. The silo is 239 feet tall, 79 feet in diameter, and used a concrete slip form mixture of 60% PLC and 40% slag. Now on to Indiana. Here is a patching project on I-65 utilizing our EcoSem PLC. PLC was used in both the pavement concrete and flowable fill. Business as usual. Now on to Canada. As I mentioned before, almost all concrete we produce in Canada is made with PLC. Just a reminder, GUL is the CSA designation for PLC. Here we have Canada's new preservation facility, 22,000 cubic meters of concrete, utilizing both EcoSem PLC and slag, having strict performance requirements. Greener concrete. How do we make greener concrete? If you forget everything else that I have talked about today, please remember these key points. PLC can be used as a direct replacement of ordinary Portland cement. Ensure that ASTM C595 is specified everywhere that ASTM C150 is. Maximize usage of SEMs like slag in your concrete mix. and use type 3 EPDs as a guide to lower the carbon content of your concrete. I appreciate this opportunity the CLF DC team has given me to present on Portland Limestone Cement and what we are doing to reduce our CO2 footprint. Although we have made progress, an industry-wide effort is needed to allow and specify low carbon products like PLC. For additional information, you can access our website or go to greenercement.com and download a fact sheet or information on how to specify PLC. If there are any opportunities for Lehigh Hanson to assist you regarding PLC or other sustainable needs, please let us know. And thank you.
Thanks, Jeremy. That was great. I guess now we can open it up to any questions or comments, discussion. So feel free to turn your camera on, unmute yourself, and ask any questions you might have.
All right, I think that answered everyone's question, which is good. Means I did a good job.
Is there anybody who's planning to use Portland Limestone Cement on a project in the DC area? I'm kind of just curious because we've been working on some projects where we're trying to get the project teams to specify it or use it in their concrete mixes.
Yeah, I think one of the things that will begin to happen, as producers, as a cement producer, in order to reach our carbon neutral goals, is that it's going to be harder and harder to find ASTM C150 cement. For example, let's take up in Ontario, where now it's almost a specialty product in order to find a straight Portland cement. As is the case with with our plants in Delta. There was a project out in Washington where the owner didn't want to use a Portland limestone cement, and it was significantly more expensive because the regular Portland cement had to be special ordered. And so that's something that's going to be coming more and more. You're going to see more and more Portland limestone cements, and it's going to be harder to find the C150 cements.
Yeah, and I know from some of our past conversations, I know Tech Chua with Vulcan joins us a lot for some of these events, and he has let us know that Vulcan has sort of been increasing their storage for Portland limestone cement in the area. So that's great. I guess a lot of projects are starting to request it. So it sounds like it's becoming more and more available in the area, which is great. Right. Anybody have anything else? Any questions? All right, well, I guess we can end a little bit early today. And you can reach out to Lehigh Hanson if you have any other questions about Portland Limestone Cement. And I'm sure we're gonna have some more discussions in the future as well. So feel free to join those, and keep an eye out for some of our future events, either in September or October. All right, thanks everybody for joining, and thank you, Jeremy, for the great presentation.
Thanks, Kirsten.
All right, have a good one, everyone.